two particles of mass 4 and 3 hang from a pulley. So we leave this 2 out at the beginning. The system is released from rest, and after 2 seconds, the 3 kg picks up a mass of 2 kg. So we'll have the principle of conservation of momentum here, and how much further will the 4 kg mass move downward before it stops. So let's start with our equations. With our 4, we're going to move down in this direction. It's heavier, so we'll call this one A. We've got our T and our 4 MA, or mg4g. So we've got our 3 and we have our T. We have our mg, which is 3g, and it'll be moving in the opposite direction. So applying our forces, we've got 4g minus T is equal to 4a, and we have T minus 3g is equal to 3a. Solving for a, we're going to get minus 3g plus T equals 3a. Cancelling your T's, we're going to get G is equal to 7a. So A is equal to G over 7 ms to the minus 2. So now we're looking at after 2 seconds. So let's see what happens in the first 2 seconds here. We're starting from rest. We've got time is equal to 2. We've got A is equal to G over 7. So we can get the speed of the system now after 2 seconds. V squared. No, V is equal to U plus AT is what we'll use here. So the new speed of the system V, it started from rest, is going to be the acceleration, which is G over 7 times time, which is 2. So the speed of the system after 2 seconds is 2g over second, meters per second. So now we need to get the new speed of the system. So we are adding on another 3. So we have the conservation of momentum. M1U1 is going to be equal to the new mass M1 and the new speed. We just call it V. So the original mass was your 4 plus your 3, which is 7, times the speed of the system after 2 seconds, which is this 2g over 7. That's going to be equal to the new mass. We've added on 2, so it's going to be 4 plus 3 plus 2 times the new mass, which is v. So simplifying this, we are going to get 7. The 7s will cancel, so we're going to get 2g is equal to 9. 729v. So the new speed of the system V is equal to 2g over 9 meters per second. And then this will enable me to get my new acceleration, which will enable me to find out how much further the 4 kilogram mass moves downwards in this direction before it stops. So we need new forces formulas. So our forces, we have now got a 4 still and a 5. T mg T mg. Now it's obviously the 4 started off, it was heavier, it's going down in this direction. It's going to come down in this direction for another bit before this one becomes heavier, but that's still going to momentarily move up in this direction. So let's call this new acceleration B. So we can say that on the 4 kilogram mass, we can say that 4g minus T is equal to 4b for the new acceleration, and in this direction we're going to have T minus 5g is equal to 5b for the new acceleration. Solving these, we're going to get minus 5g plus T equals 5b, and you can see here it's slowing down before it changes direction. So we're going to get minus acceleration minus g is equal to 9b, so the new acceleration is minus g over 9 ms to the minus 2. And now we want how far it's going to fall. So we've got the new speed of the system, we've got the new acceleration of the system, so we've the 2g over 9 with the acceleration. So using v squared is equal to u squared plus 2as should give us this. It's going to come to rest, so that's 0. So I've got my 0 squared is equal to the new speed, 2g over 9 squared. We're looking for distance, so plus twice, that's where we're going to get a negative acceleration, minus g over 9 times s. So we're going to get 2gs over 9, bringing it to the left, 2gs over 9 equals 4g squared over 81. So I can multiply both sides by 81. I'm going to get 18gs is equal to 4g squared, dividing across by g. I'm going to get s is equal to 4g over 18. So s is equal to 2g over 9. And that would be meters in the context of the question.